exponents. Goals for this lesson. I understand how to combine exponents. 2. I understand what cases I can add exponents and what cases I can multiply. Welcome back, and today we'll be exploring exponent operations. Let's try these out. So first we have 2 squared times 2 to the 5th. Okay. So what do we do here? What are we supposed to do? Do you know? Okay, so if we have 2 times this, well, we can actually rewrite this as 2 plus 5. The reason why we can do this is our exponent rules are whenever we multiply exponents, they get added together. However, we must have the same base for this to happen. So if we want to multiply exponents, they must have same base. Okay, so the reason why this works is because we can do 2 plus 5 equals 2 to the 7th. Okay, so now let's expand all of this out. Okay, so we have 2 times 2 squared times 2 to the 5th. So we have 2 times 2 times 2. Okay, and then we have 2 to the 7th, which equals, the dots are equivalent to times. It's just different notation. Here, I'll put it back in the other notation just so you can see both ways. So we have that times. Alright, so we have this. This is equivalent to this. So we have 1, 2, 3, 4, 5, 6, 7 twos there, and 1, 2, 3, 4, 5, 6, 7 twos there. And we can just put parentheses around, right? So they are equivalent. But what happens if we use a different base? So let's experiment with that real quick. Okay. So say we have 3 squared times 2 squared. So we're going to have 9 times 4, right, which gives us good old 36. So now let's say we made up some rule such that we can do this. So we end up with 6 to the 4th, right? So 6 times 6 is going to give us 36, but now we have 2 extra 6s. So it doesn't work when we have 2 different bases. Alright, now let's move on to our next operation, addition. What do you think we should do here? What do you think the right way to go about this is? If you said we can't combine these two, you would be correct. So 2 squared plus 2 to the 5th equals something. So technically, if we combine these and we got this, we would get 2 to the 7th. So let's explore this. So we have 2 squared plus 2 to the 5th. This is just the same thing, would equal 2 times 2 plus 2 to the 5th. I just don't have enough space to write that out. And then we have 2 to the 7th here. So we already explored 2 to the 7th. We know what that looks like, right? 4, 5, 6, 7. But then we end up with 4 plus 2 to the 5th, which, can we agree that these are not equal? So if we have addition, everything stays the same. We don't combine any like terms. Now let's say we have 2 to the 0. Typically when we have a 0 in multiplication, right, we just end up with 0, but we have an exponent raised to 0. It's a little bit different. So essentially what we get is just 1. 3 to the 0, 10 million to the 0, all are just going to equal 1. That looks like a 2. 4 to the 0 equals 1. Anything raised to the 0, 0th power is 1. Makes it pretty simple. So if you have 2 to the 0, just 1. 5 to the 0, 1. Literally 1 billion, trillion, million, gazillion to the 0 is just 1. Okay, now we have a negative exponent. What do you think that this means? So when we have a positive exponent, we just have this, right? So the only difference between this is just we do 1 over this. A negative exponent denotes a fraction. So if you have any sort of negative exponent, we're going to have a fraction. So if we have 3 to the negative 5, it's just 1 over 3 to the fifth. Negative just means fraction. I know it's a little abstract. I know it's a little weird, right? Because it's counterintuitive, but it's just one of those things you just have to kind of learn to recognize and learn to kind of be like, okay, I know that this is always going to be a fraction. It's just one of those math things that you should learn to recognize and understand that if it's negative, it's going down in the denominator. The other way you can think about it is like 2 squared would be on top of 1 technically. So if you got a negative 1 there, we send it down below the line. 1 over 2 squared would be 2 to the negative 2. I know this is a little abstract and I know it can be a little tricky, so it's make sure you do lots of practice with these. These are important for like algebra. Next, we have a negative exponent times a positive exponent. So let's just take a second to think about it, right? So we know that whenever we multiply two exponents together and they have the same base, which we have here, that we're going to add. So if this was a positive exponent, we would have 2 plus 5. So now that's a negative exponent. It looks a lot trickier, but I promise it is super simple. It's just subtracting. Negative exponent, we just subtract, right? So we get 5. Oh, that is not a 5, that is a 2. Okay. So another way to write this is we can say 2 to the fifth over 2, 2. So remember when we have like a same base, we can just we can cancel it out. We're just doing the same thing here. So we know that we can take 2 out of 5, so we end up with 2/3. Both ways are correct ways of thinking about it. The one I recommend is the one that works best for you. So you can either just set it up as subtraction, which works beautifully, or you can think about it in a fraction bar. This way is a little bit more abstract, but this way is much friendlier if whichever way works for you though. So now let's do some practice. So we have 2 squared times 2 to the fourth equals what? We just add the exponents, so we get 2 to the sixth. Now say we have 7 to the 0. What does that equal? That's right, 1. That equals 1. And then now let's say we have 7 to the negative fifth times 7 to the eighth. We just subtract, right? 8 minus 5 equals 7, 3. Alright, now let's review. So multiply, of course this is with same base, add exponents. This is shorthand for exponents. So now we're saying we're adding, do nothing. We do not combine exponents. Now let's say 2 to the 0, always 1. Negative exponents, subtract.